Okay, thank you for joining us. My name is Hugo Gonzalez. I'm application supervisor here at Mimaki. And today we're going to have a presentation with Laser Dave at Trotec. We're going to start with the video presentation, and then we're going to answer questions live after the video presentation. Feel free to submit your questions in the room chat, and we'll be answering them after the presentation. Thank you.
Well, hello everyone. My name is David Stevens, also known as Laser Dave. Today's course is titled How to Use Printing and Laser Finishing Together to Add Depth and Value to Your Products. This seminar uses QR code links. All you need to do is turn on your camera app on your mobile device, point the camera at the QR code, but don't take a photo, and a link will show up on the screen. Select that link to get quick and easy access to web links, files, and videos. Trotec is a very social company. If you want to keep up with current events, trainings, products, applications, and laser materials, please scan the QR code and subscribe to your favorite social media platform. We are on YouTube, Facebook, Instagram, LinkedIn, Pinterest, and Twitter. Today's outline is going to give an overview on laser technology for those folks out there that may not be knowledgeable on the technology. The components of laser systems, what common materials the laser will process, choosing the right laser system, and how to choose that system, as well as accessories, and then we're going to get into some printing and cutting with lasers on everything there is to know about the process. And then finally, at the end, I will go live and we can answer any of your questions. Throughout the course, please post your questions online and we'll be happy to answer them at the end of the course. The first section here is laser technology. What is it? How does it work? All the details about it. Laser technology is an extremely flexible process that can be applied to a broad variety of businesses. Laser systems can cut, mark, and engrave literally thousands of distinctive materials in a wide variety of shapes and sizes. Laser systems have some simple components in order to work. A simple work surface and motion system, a laser light source, which is the laser beam itself, integrated control software that controls that laser beam, optics that deliver that beam to the material substrate, as well as optional accessories, for example, rotating around products and cutting out materials, which we will get into. Laser systems have the ability to engrave, mark, cut, and fuse into materials. Engraving is the process of actually engraving depth into the surface of the materials. Materials like leather, wood, rubber, and so many more actually produce depth when laser engraved. It actually produces distinctive depth into the material. When I use the term laser marking, this is the process of changing the contrast on the surface of the material. No depth is achieved, however high contrast marks are achieved by surfacing onto materials like coated metals, engravers, plastics, and materials like that. Laser cutting is just applying enough laser power at low enough speed to completely vaporize the material all the way through, cutting through. Not all materials can be laser cut, especially with some of the standard 10.6 CO2 laser. Basically, if a material is combustible, the laser can cut it out. If it's a non-combustible material, such as stone, metal, and glass, we can laser mark it, typically is all. And then finally, we have laser fusing. Laser fusing is the process of actually additive, or adding a material to the surface of a material. So, for example, like a welder would apply a surface type weld, laser fusing does the same. Additives are added, and we're able to actually fuse and produce contrast marks onto materials like metal without the actual penetration into that metal. Materials such as Surmark, Laser Bond, and Thermark will work with this process. One of the most common materials that can be laser processed, and actually one of my favorites, is woods. Woods are a great material to process. It can be cut, it can be marked, it can be engraved. All the different types of colors and species and grains, plywoods, MDFs, all the different types can be processed with the laser. They all are cuttable, and as you can see, they are very engravable. A high perceived value material, especially in the printing industry, when printed on wood and you can still see some semi-grain, it adds a higher perceived value to the finished product. So wood is a great material to laser process. Plastics are another very, very common. Lasers work extremely well with plastics. We can cut them, we can engrave them, we can mark them. All plastics will work. However, there are some types of plastics that can be dangerous, mainly PVC or polyvinyl chloride-based plastics. These produce a chlorine gas, and it's not that they won't cut and engrave, they will actually cause damage to your laser machine, and it is the only plastic we do not recommend. However, your types of Trolase plastics, ABS, acrylics, polypropylene, polystyrene, and so many more can be laser cut, laser engraved, laser processed for unbelievable results. In addition, the print and cut methods, being able to print onto the surface of plastics and then place them into a laser machine and then cut them out, really does add that next layer of quality when processed. Stone is another popular material, can be very easily etched. The darker the stone, the higher the contrast typically. However, stone works very well. We cannot cut through the material, but it is a great material to laser process, but it cannot be cut. Metals can be marked. Coated metals, of course, the laser will etch away that coating. Anodization, painted, powder coated. Using the fusing process like metal marking compounds, it can be actually fused on and turned dark. Fiber lasers, which is another laser we manufacture, will mark directly into the metal and can also produce depth into the metal. Papers are another very very laser-friendly product, from cardboards, thick cardstock, thin paper, vellums, any type of thin film type paper materials. Works very well. Some papers engrave okay, but typically most paper do not engrave with great contrast. It is primarily used for cutting. Glass and ceramic is another popular laser material. It will produce a nice frosted, kind of sort of sandblasted look. We can't really produce depth with a laser, but we can get that frosted effect into the surface of glass, which gives us a nice contrast and a very, very nice finished look. Accessories like the rotary device will allow us to put a fourth axis into a laser system, in addition to the laser engraving on flat stock, and allow us to rotate around that, which I will get into shortly after this. Rubber materials also work very well. Rubber stamps are traditionally made with lasers. It is the most effective way to make a rubber stamp. Gaskets, seals, and other type of stuff is also very popular with laser technology when processing rubber. Fabrics and leathers are another very popular one. Most fabrics tend to be just cut. Some can be engraved as well, depending on the type of fabric. However, engraving, most fabrics don't work as well. Cutting works extremely well. Leathers also engrave beautifully onto the surface, as long as it's a nice vegetable tan surface toned leather. This is a great material to work with. In addition to cutting fabrics, typically the laser, especially on your polymer-based fabrics, the laser, heat of the laser will actually seal the edges, producing a very, very nice sealed edge. So printer technology that can print directly on fabrics, and then using camera registration, which I'll explain later, you can very quickly and easily print on fabrics and then immediately use camera registration to register and then cut it out for sewn-on patches and other products like that. And then other, just to kind of show you the diversity of lasers, there's really no limit. I mean, we've engraved on everything from bread to chocolate to leaves to, rocks picked up outside. There's very little limitation. It's purely focused heat energy in the infrared spectrum. So we can effectively laser mark virtually any kind of material. Some work better than others, but as you can see here, there's an unbelievable variety of possibilities using CO2 laser technology. Now, the systems configuration, there are a lot of laser systems out there and a lot of types out there. Most of them will produce all the products that I just shown, that were just shown. However, there are a lot of different types of technologies out there. Trotec alone makes many different products. Well, my last count was 28, 29 different models of laser systems. Each model is going to give different capabilities, different sizes, different powers. So higher laser powers would be able to cut through thicker material. Lower laser power would give you more contrast and more detail. Larger field sizes would allow you much larger finished products. And so if you have a large format printer and you need to be able to make large printed signs, our large format lasers would be the right solution for you. So I'm going to go through a little bit about the Trotec product line just to give a basic understanding. Even the small ones will typically do the same things as the big ones when it comes to physical material types, but your limitations are typically the amount of laser power and physical size. Rayjet 50 being the smallest entry-level system that we make, starts at 30 watts, gives you an engraving area of 18 by 12 inches. Nice little desktop model, great starter machine, and it's an outstanding high-performance little laser system, especially when you need space saving. Our R400 and R500 are a glass tube laser cutter that are very affordable. These systems are designed for cutting only. They do not have camera registration. However, they are a very inexpensive, large field size laser cutting system. That's primarily what they're designed for, is for cutting. They will engrave as well. However, they are nowhere near as fast as the engraving type machines like our Speedy line, which I'll get into next. The Speedy Series is our most popular by far. Lots of different lines. We have our Speedy 100, Speedy 300, our 360, and our 400. As you can see, as the line gets larger, the Speedy 100 goes up to 60 watts. The 300 goes up to 120 watts. The same with the 360 and 400s. Larger the machine, you're going to also engrave faster. And then, of course, you have the larger field size to be able to push product into it. You also have a lot more options and accessories on the Speedy line, such as your camera registrations, rotary fixtures, different tables, which I will show in a few. The SP series is our largest field size. When you need that in very, very large field size, laser cutting and engraving of systems up to 200 to 400 watts, depending on the size, and field sizes up to 87 by 120, almost 127 inches. So these systems are going to give that very, very large field. Camera registration, no rotary accessory, but these are primarily used for large format engraving and cutting if you need that extra size. Accessories to work with our lasers will be determined by what your application is. Laser systems work based on any graphic design software. Most common is CorelDRAW, Adobe Illustrator, AutoCAD, and EngraveLab, but there's so many others out there that'll work. Basically, if it's a vector-based design software and you can draw on your file or you can draw on your screen, the laser will interpret that vector file as a cutting and engraving path. The laser works just like a printer, so you can hit print from anything and actually engrave it, but if you want to cut with the laser, it does need to be a vector software. In addition to the laser systems, you do need an exhaust system. Most will ventilate outside, but you could also go with a filtration unit. Because we are burning the material with laser systems, a ventilation filtration unit or external exhaust is necessary to vacate those fumes when laser processing. So this is an accessory that is absolutely required when processing with the laser. Air assist comes standard on most of the systems. Air assist actually blows air down on the cut, keeps any flame and debris from happening or damaging the optics. It's a great option for the systems. In most cases is highly necessary for if you're planning on doing any type of cutting. Rotary is also very popular, allows 360-degree engraving around any type of cylinder, conical, or round type objects. You can actually do pens and bottles and glasses and stuff like that in the machine. Different machines, of course, are going to have a larger or smaller rotary depending on the size of laser system. So depending on the size of product will depend on what rotary will fit into that laser system. Larger machines, larger product. So, for example, a Speedy 400 is large enough to support a full-length baseball bat for engraving. However, like a small Rayjet 50 would only be able to do, say, wine glasses and little bottles and stuff like that. Different cutting tables are also available with the systems. We will help you configure most of these products. Cutting tables give us the ability to produce better quality cuts depending on the material and substrate that you are planning on processing. So after the laser or the printer has printed it, or if you're planning on just cutting materials, there are lots of different cutting grids that are optional. The aluminum cutting grid here in the lower right-hand corner is the most popular. It can be engraved on, it can be cut. We also have flat tables in addition to the cutting tables. tables, which will allow for a full vacuum table as well as a magnetic table where you can use magnets to hold your products down. Lenses, many different lens choices. This is going to give more tolerance. It's like different lenses on a camera. Some of them give you the ability to go real close up, other farther away with more tolerance. Is a benefit to using a shorter one. It's going to give you more detail but less tolerance. So higher quality engraving, but higher resolution. As you go further in lenses, you get more tolerance but less resolution. So most systems will do 2 or 2.5 inch lens, which is going to give you a good contrast in engrave quality as well as a good cutting lens. Additional lenses can be added, as well as most of the accessories can be added at a later date when and if they are needed. The Ruby laser software is the interface software that works with our laser systems. Mainly our Speedy line. Right now this is not for the Rayjet or R4 and R500. However, the Speedy line of laser system uses the new Ruby software. This is a web-based or Ethernet or network-based graphic, so it can be run from any PC, Mac, any type of mobile device you can access it from. It is a great system for importing it. You no longer need to use Windows. You can import directly. It imports formats automatically. You can drag them in. You can import them right into Ruby. Simple formats like SVG, PDF, DXF formats, as well as Adobe Illustrator and CorelDRAW formats directly into the software. And now if you're just engraving, it'll also support file formats like PNG, JPEG, bitmaps, where you can bring those files directly into it. You can add cut lines. It gives you the ability to do drawing capabilities, modifications in the software, and it makes it very, very user-friendly for processing it. If you want to know a little bit more about how our laser systems work and want to actually see a process of the entire flow-through of bringing a file into our laser software, processing it into Ruby, and then sending it to the laser, you can scan this QR code and learn more about this software. If you are running a laser system, this software will be the software that you will use every time a file is sent from your design software, or you can create it from scratch from the Ruby software. But scan this QR code if you want to learn more about the interface and the ease of use that it takes to run through the software. The other nice thing is most materials are pre-programmed, so you're not putting in parameters or settings for the laser. You would just bring in your design file, you would select the type of material, acrylic, wood, plastic, whatever it is, off of a list of materials, and then send it to the lasers, making it very user-friendly to process with Ruby software onto your laser system. Now, printing and cutting. Now that you kind of have an understanding of what laser systems we produce, options, accessories, kind of what lasers can do, what materials those materials will process with, something in this course, especially working with Mimaki, is the ability to print and cut. As of course, Mimaki can print on most materials, especially with the UV type printers, printing onto the surface of plastics and woods and other stuff like that. Combine that with the power of a laser system, you now have the ability to actually cut those products out with perfect accuracy. When the actual graphic is printed onto a substrate like plastic or wood or any combustible material, the laser can cut that product out. By simply printing registration points that are 6 millimeter or just smaller than 1/4 of an inch in diameter black dots onto the surface surrounding the graphic. We need at least 2 to 3. I would recommend 3 or more. As you go up 3 or 4, you're going to have more accuracy. But what this does is, combined with a camera system or a vision system, it combines with the laser. The optical camera goes out and finds these registration points and gives us a perfect cut, no matter how that product is placed into the machine, without any bleed. So the laser is accurate enough to find those registration points and then give you a perfect cut, so there's no leftover ink on the finished product or on the scrap part that's pulled away. And as you can see here from these few samples, the process is very, very seamless. And I'm going to show you a little bit, since this is a little more useful for the Mimaki crowd, of exactly how this process works. Now, systems that the print and cut vision camera is available with is our Speedy 300, 360, 400, 500, 1500, 2000, and 3000 laser systems. Our smaller Rayjet and R series does not support the camera system. So in order to have this capability, you would need one of these models in order to process with a camera system. That doesn't mean that machines like the R400 or Rayjet series can't laser cut the material. Say if you are printing something out, making it slightly smaller on the cut and want to cut something like a puzzle, that's easily enough done with just using a red pointer for targeting and then cutting slightly smaller, leaving a little bleed, and then you can cut that out. But camera registration gives us the ability to go beyond that and give us that accuracy. Camera registration software is included in the program in JobControl Vision as well as Ruby software, and it eliminates the need for any type of third-party registration software. Used for any type of pre-printed material on the variety of substrates, as we just called. It's a digital USB camera that's included, easy to remove and pop on and off as needed. And the way that it works is basically you would bring your design in to the design software. You would print it on the printer. Once it's printed on the printer, then you can, of course, stick it into the laser and then cut it out using camera registration. And I'm going to show a video on the process here next. But the process needs to be designed correctly. There's typically 2 files that are created in order to make this work. And so here we go. First thing you do is go ahead and just place the camera on. As you can see, it slides directly onto the laser system. 2 thumb screws will give you the ability to lock it into place. It is a USB powered thing, or a USB powered camera. But then the printed technology camera will actually go out and search for the registration points, and then it will give you a perfect cut. In this case, I can use the laser to score and actually produce fold marks, as well as give me a perfect pre-registered cut path. The laser system will, once finished, will then beep, and then you can pull out that finished product, no bleed laser cut product. This is an outstanding process and a very, very easy process to do. The next step here is I'm going to go ahead and show you exactly how to design and create the graphics using your design software. Now, design software, I recommend CorelDRAW or Adobe Illustrator to do this. It can be done in multiple pages or it can be done in multiple layers. But simply what you will do is you will design a file. The first file would be sent to the printer here. As you can see, we have just 4 registration points, and we'll send that file to the printer. This can be sent to any printer, of course. In this case, I just have a paper printer here. And in this case, since I don't have a UV printer, I can apply a backing to it, and so I will apply a material. Then I'm going to apply a cut setting. You can see red will be cut, and then a black outline of the lines or the registration points there in the corners will be our second layer, and this is the part that is sent to the laser. We'll go ahead and save that file as a PDF or a CorelDRAW or Illustrator file, and we'll just place the finished laser cut product in the laser. I have adhered the paper to a piece of acrylic, so it simulates a UV printed product. Process is the same. Then we'll use our red pointer to just manually place the red pointer somewhere over the registration point. And I'm going to go into our Ruby software, and I'm going to open it into the Ruby software just by importing it in or dragging that file in. We're then going to fit the file to the design, and we're going to create a job. This is the Ruby software. It works very, very simple. And the little crosshairs on the center of the screen here is where our red dot pointer is. And so all I have to do is just drag the file so that it somewhere touches that red pointer. This is just telling the camera where to start. And then that camera is then going to find the rest. I'm now going to select the material I'm going to laser process by typing in the type of material. I'm going to turn on camera registration at the top and then assign the color black to print and cut. So black is being assigned to the camera system to find for registration, and then red will be for cutting. I can identify how the camera registers and processes the camera, but in this case I'm going to just make sure to do auto detect or full nonlinear, so that it automatically detects the type of camera or the type of the cut it is, and then I'm going to push that to the laser, and then I'm going to push start on the laser. And then the camera will go out and actually search for each one of the registration points. You can see in the upper right-hand corner, the camera registration finds each one of the locations and then immediately sizes, scales, skews, and rotates the digital cut file to match the print. Even if the printer is slightly askew and it is not giving me the perfect cut, the camera registration will compensate for that, giving me a perfect cut every single time. Once finished, you can then, of course, pull it out of the laser system for your finished product, making this very laser cut, print and cut camera registration little puzzle here. Here's another example that's something that's already been printed on a hardboard. Camera registration file is going to look like this. Printed file is now placed into the machine. Camera registration comes out, finds the registration points. The more registration points, the more accurate it becomes. As you can see there, it takes just a few seconds to find it, and then compensating for size, scale, skew, and rotation to give me the perfect rotation. This is a nice hardboard with a like a lacquer finish on the surface, so even though it is a wood, that nice finished result can be just wiped off afterwards, and then you can pick up the machine or pick up the finished products for that finished, nice, beautiful laser cut product. As you can see, this process is stunning. It works exceptionally well. There is very little difficulties. If you don't have the camera registration, you can print same type of products onto the surface of products. Use your red dot pointer to slightly target, and then of course make your cut file just slightly smaller than the product itself, giving yourself a little bit of bleed. No camera registration. In this case, I'm able to go ahead and just cut that product out, wipe it down, and now if I wanted to cut that, just cut it out for an edgeless cutout, or if I wanted to cut it into a puzzle, for example, I could very quickly and easily do that. So this process will work without a camera registration, but if you want that accuracy, you would need that camera registration. Here's another example of that same type of product, also being cut out, using the red pointer, leaving myself a little bleed, and then cutting it into a puzzle. Once you would do this, though, I would take a piece of transfer tape and place it over the top. Another laser hack to get the products out so you're not picking up every single piece. This way you can wipe the backside from the heat of the laser. And now you have a printed product onto a piece of hardboard or plastic or acrylic, and then the laser cuts it out, and you've got a very, very effective personalized puzzle. Well, that's it for this course. If you are interested in some more information on processing with laser systems, I have many, many, many different types of laser seminars out there, as well as laser hacks on our YouTube channel. If you scan this QR code, it'll take you to all my different types of YouTube training courses. Feel free to go on there. Post any questions. We keep an eye on that constantly. So if you do have any questions, we'll definitely there to answer them and get you and help you out as you evolve into different processes, materials, products with your laser system. Thank you so much. Again, my name is David Stevens, Laser Dave. We're now going to go live and answer some of your questions.
Thank you, Dave. That was a great presentation.
Thank you so much.
Now we've got a few questions that are coming in. And honestly, I mean, I have a few of my own because I wasn't aware of something like the hardboard. Is that a transfer print process?
Yeah, the hardboard, the one I did was actually used with a heat transfer, or what do they call the sublimation type printer. And so it's actually sublimated and then it's heat transferred and then put on. The direct UV printers can print on the hardboard too. The nice thing about them is they have that nice white glossy surface, which is then printed on. UV printer would work just as well, but the stuff cuts beautifully on the laser.
Oh no, our textile applications, our transfer sublimations specialist is, I'm sure she's taking notes. She actually also wants to know what textile medias or are there any textile medias that you recommend that you don't cut on the laser?
I've never come across a textile that cannot be laser cut. Again, I mean, if it does have PVC in it, but I've never come across a textile that has PVC. Typically, they're polyethylene, polyester, cottons, and stuff like that. And so, I mean, it really comes down to what can you print on, and is it going to give us enough contrast for registration points? it does require enough contrast. And so if you've got like a black registration point on a black fabric, unless you can print white, you just need that contrasted registration point. Doesn't matter what the fabric is, and it should give you an accurate cut. I've done fabric with registration points cutting like patches that are going to be sewn onto hats. And I had 170 registration points because the fabric tended to skew and stretch, and it was difficult to hold flat. So we could increase the amount of registration points to get more accuracy when cutting large sheets of this out.
Okay, great. Yeah, and with some of the materials that we've had, we were a little uncertain with the polyesters because I thought I heard that the polyesters had similar chemistries to the PVCs, so
Nope.
we just generally avoided them. But I know anything that would have PVC in it is definitely a no-go. We have another question here. Can you cut printable material made of polyurethane, which you just answered, HTV with the equipment?
Yeah, high density or high polyethylene. Now, polyethylene is a low melting point thermoplastic, so you will thicker material becomes a little more difficult. It's not that it won't cut; it's just your edges start to roll back a little bit from the excess heat. Thinner materials up to, I would say, up to 3 to 6 millimeters is definitely possible, or 1/8 to 1/4 of an inch. But any thicker than that, it really depends on your wattage. Plastics aren't a problem in general, but the edge quality can start to suffer when they're really low melting point plastics like that. But thinner materials, which is most common, should not be a problem.
Okay. And what if we want to print on black material? How will registration show on that?
Well, I mean, the key is with registration is contrast. You need the contrast in order to achieve the registration component. So, I mean, if your printer has the ability to print a white backdrop or just make the registration points white or silver or some dissimilar color away from that material, the camera registration will pick it up. It doesn't matter what color it is.
Okay, that's great to know. I typically end up printing, the black registration with just a little circle of white ink around it just to make sure it has
That
high
works
enough
just as
contrast.
well. Yeah, especially on materials like clear can be tricky because when you're
Yeah,
printing clear, if you just do a black registration point, when you hold it up to a light background, it looks great. But when you put it on like a dark cutting table to cut with a laser, we're not able to see that. So in that case, we need some type of surrounding white, or if the acrylic or something has like a white transfer or a coating already on the back side, which gives you the contrast, that works. But in the case where it's going to be peeled clear and it's going to be laser cut clear, you want to print some type of surrounding color and then just design that in your graphic software when before it's printed.
right. Yeah. Yeah, if we forget to print it, then we tend to put little sheets of paper under each of the registration points.
Then they're done that, definitely.
Yeah, it's like if you forget to print those.
Yeah.
So what kind of cleaning or finishing solutions are best when working with a laser?
I mean, it depends on the material you're processing. Most plastics and stuff like that, you saw like the hardboard, it was just a damp cloth. There's no solution or anything like that. Some plastics, if you get a lot of residues on plastics, I like because alcohols can actually cause cracking and fracturing on plastics. If
Right.
it's cleaned with an alcohol solution, we try to stay away from them. Ammonia can also cause them to cloud. And so what I found is I worked with a chemist and actually found a cleaning agent that worked extremely well on plastics, mainly acrylic-based plastics, and that is a hexanes or heptane. It's a petroleum-based cleaner, and we're able to get a perfectly clean response when cleaning these type of plastics from any type of residue and debris that come from the laser cutting process or engraving process.
Okay. That's great to know. I know in the past we'd heard that if you have if your acrylic is scratched up, to use like a car wax on it, and it tends to fill in the little cracks. I haven't verified it. I haven't asked any of our acrylic manufacturing partners on that one. That'd be an interesting one
Yeah,
as
I
well.
mean, in essence, that's what a car wax is. It clears those little fine micro scratches. That's why people wax their cars. It does the same thing. And so, pending that the scratch is not too noticeable,
Right.
yeah, you can buff that
Yeah.
out, as they
Any
say.
surface stuff. Okay. Is it recommended to put a border to laser cut when printing with UV ink?
um, put a border. I guess I'm not.
I'm assuming they're meaning like, can you cut through the ink, or do you need to laser outside of the ink.
Oh, no. Yeah, you can definitely cut through the ink. There's no issue with it. The UV ink has no issue. Now, you, of course, want to use the right agents to bond to the acrylics or plastic so that it sticks on. One issue I have come across sometimes, especially on the thicker UV, once the laser goes through, if the hand is rubbed right on that edge, it can peel that ink off the surface because it kind of releases it through that, through the process of cutting it. So as long as it's bonded properly, the laser has no issue and it doesn't cause any issue with the machine, gives you a perfect cut. The concern that I have found is that the ink stays on and it can't be taken off after the laser comes and cuts it out.
Right. And I guess it's my perfect chance to plug in that we do have a printable primer that we could also be added. And of course, it depends on the brands of acrylic. There are acrylics that are pre-treated and some that are not. And in the ones that are not pre-treated, we recommend the printable primer works really well.
Yeah.
With some of our, especially our flexible inks, and it prevents that. But cutting through the ink, definitely don't shy away from that.
Yeah, that's one thing I've run into the most when UV printers print on acrylics and then laser cut it, is that bonding effect. And so making certain you run a few tests, make sure that it works properly, cut it just a small little area so that it bonds properly, especially before you send that finished product to a customer.
Okay. Another question that we're getting is, I guess a little bit more for me. Will I need to use a specific ink set for to laser properly? No, actually, across the board, it depends on the adhesion with the acrylic. It does vary a little bit by types of acrylic. Generally, all of the inks cut well with laser. Using acrylic. I guess I'm thinking of acrylic specifically, but if you're using other materials like the cardboards, cardstocks, or papers, we generally don't have any issues between types of UV ink. And we're also getting another question. If we could elaborate a little bit more on those, on the laser engraved photographs. Am I?
Oh, the laser engraved photographs.
Yes.
Yeah, the photographs. I think that's what they're talking about, right?
Is that I believe you had some on rock?
Yeah, I can laser engrave a photograph on anything, but basically, I mean, it's no different than a printer applying little dots of ink. Think of old school inkjet technology or dot matrix type technology. It places little dots to give you the appearance or shading of a graphic. The laser can do the same thing because we can fire that laser so quickly. We can fire and not fire to produce contrast, and so more engraving in a specific area produces a darker response on something like wood, and less areas give you the effect of less shading. And so in essence, we're able to do that dot matrix style print or engraving to get really nice, realistic looking photographs up to 1,000 DPI with laser technology directly into the substrates of material. So no printing whatsoever. We're literally taking a photograph and processing it right onto the material. I have a training seminar on our YouTube channel that'll walk you through the entire process. Go to Trotec Laser USA on our YouTube channel and just type in the word photo in the search, and you can watch that. It's about an hour long, goes through the entire process, every material, lens types, everything you ever wanted to know on how to process photos with your laser system.
And you said that was TrotecLaserUSA.com?
Trotec Laser USA YouTube channel. So go to YouTube and type Trotec Laser USA. Each country has a different has a YouTube channel. So when you type Trotec Laser, you may get Canada, you may get Australia. USA is where all my stuff is stored.
Right. That's how Mimaki is set up as well. Our local is Mimaki USA as well. Okay, actually, and a couple questions that came up for myself. I noticed that you had the different tabletops for different materials. And honestly, I'd only seen the aluminum one, the aluminum grid, and then the aluminum flat one. Can you tell me something that there was one called the aluminum or acrylic slat table?
Yes. We have different cutting tables specifically for different materials. Now, especially when you're doing intricate cutouts on acrylic, you tend to get the aluminum, like cutting grids can tend to produce little reflection points on the backside. So if you're doing print and cut and you really want to be able to see a clean, smooth edge, you'll see a little reflection point when it hits a metal cross rib of an aluminum cutting grid. So we have optional acrylic ones. So it's kind of like a sacrifice material. So when the beam goes through, we're not getting any little reflection point, especially if they're going to be backlight or side lit up. You really start to see those little reflection points. And so we offer different tables in those rare cases where the edge is going to be lit up, or if it's going to be seen, or if it's causing issues. Most people will use the aluminum one because it's fine. But there are cases, especially on thicker materials, where that can be a problem. And so we offer the additional tables in those rare cases.
Okay. Oh, that's great to know, because I have noticed the little like hot spots. I always assumed that it was that the laser was heating up the aluminum grid a little bit, and that caused a little bit.
It's actually a reflection. The beam is reflecting straight back into the material, and it causes a little tick mark, if you will.
Ironically, I always watch out for those little flash points, so I know that the laser's going all the way through on the first pass.
That's true. That's true.
So it's like it's flashing. I'm good.
Another cool thing I wanted to bring up here too is something that I get a lot of questions on is when you print on clear acrylic, the really neat effect is to mirror your graphic so that when it is finished cut out, you flip it around so you're looking through that clear material to see the ink on the backside. It really does create a neat effect. And in those cases, you really do start seeing those reflection points. And that's when the aluminum cutting grid table, or if you're doing bigger stuff, the slat cutting table also works. You can also elevate your acrylic over. I got little laser hacks on our YouTube channel that tell you how to elevate up on pins that are put onto your aluminum table if you don't want to invest in another table. So there's a lot of different ways to get around that.
Yeah, I tend to keep scraps from the cutouts and put them under the print area that's not going to cut. So it's lifted up another thickness.
I have a little laser hack that it's a perfect little T that slides perfectly into our cutting grid, and so it doesn't move around. It allows you to kind of position them. It works really well, and you can cut the T's on your laser.
Nice. At the start of your presentation, you mentioned that kind of your entry level point was the 30-watt laser. What does 30 watts mean in terms of like cutting ability, or like how do you rate that? Because I know we have an 80-watt. I believe they said I could cut half an inch of acrylic in one, depending on the lens.
Yeah, you're absolutely right. Wattage is basically, it's like engine in the car. Any wattage will eventually get you there. Cutting can be tricky though. I typically 30 watt, I wouldn't go much more than about a quarter of an inch. Some people even opt around an eighth of an inch, depending on the material, something like acrylic, for example. On an 80 watt, I've got through as much as 3/4 of an inch, but it's not real practical because it's so slow. So it's power versus time. Going slower is the best method. Multiple passes can happen, but your edge quality starts to suffer. So you want to get through in one clean pass. So higher wattages will give you the ability to cut through thicker, and it will also faster on thinner materials. In addition, when engraving, low wattages will give you more control and more detail. So you have more control over that laser because it's just not as powerful. It's like trying to do the speed limit in a race car. It's hard to do when you have high power, but when you have low power, it's easy to do the speed limit. And that's how lasers work as well. So low powers have their advantages, giving you more control. And also because you cut through thinner materials slower, your edge quality is a little better. Where really high laser powers cut through so quickly, it doesn't allow them plastic to melt as much. And so your edge quality, believe it or not, on thin materials will not be as good as low wattages. So depending on what you're doing, most people tend to be in that 60 to 80 watt range, which is the mid range, kind of the best of all worlds.
Okay, great. And it looks like we're just about out of time. Thanks for presenting this. This is a lot of great information for us. That definitely piqued my curiosity. And as you mentioned, you have the YouTube channel at Trotec Laser USA. So definitely check those out. I've seen a lot of your classes. I know the last one I saw was you were engraving on, I believe it was handles, like knife handles and things like that on the wood.
Yeah,
that was a great presentation. I was like, oh wait, I never thought to personalize, items like that. It's a great idea because we have our 360 here in the back, which we love to do a lot of projects on.
Awesome.
Yeah, so thanks for joining us today, and thanks for being part of Innovation Days. And we'll have this video available to anybody who missed soon after this presentation. And we'll have your contact information available for anyone who wants to get in contact with you or know more. And
Excellent.
actually, if I might ask Kelly to maybe type in your web address so that they have a direct link to your information page right now. All right, thank you so much. So for anyone who's interested, can record that. Otherwise, we're done for the day. Thank you for joining us today, and we'll see you again for the rest of Innovation Days programs tomorrow and Friday. Thank you.
Thank you so much, everyone, and thanks for joining us.
Thank you, David.